Hi everyone, today in this video I'm going to talk about another mental model that's obviously important in order to take better type of decisions, which so ultimately is going to bring better results in your life, whatever is the field that you want to get prosperity. You can talk about in terms of building wealth, in having health, in relationships and family. Whatever field you have, you kind of need to accomplish targets in order so to get to a end goal, and for that you're gonna have to have kind of mastered the decision making, which so it's something that can be said that is a methodology, and methodology is why the mental models can be important since they're methodologies in order to perceive reality. So I would expect you to help me by subscribing and afterwards seeing other videos in order to make you a better person. And today we're going to talk about the TRIZ. It's a framework used by a lot of genius people that have as a utility the possibility of increase the likelihood of has to innovate. So the TRIZ, pronounced as TRIZ, stands for Theory of Incentive Problems or of Inventive Problem Solving. It was developed by a Soviet engineer, Genrich Altschuler, who analyzed over two, more than 2,000 patterns and discovered that the most innovative solutions followed predictable patterns. So all the type of solutions that this specific engineer seen that was created, they had the same type of pattern that leads towards innovation. And as another type of methodology learning, that's the way that we see. So we observe the reality, and we have some hypotheses that we take from observations that in the science field we have like a group of control, a group of tests with test so a specific type of medical substance or something that you want to test, and we compare the different feedbacks that we got from the two different groups. If a group of tests had some type of indicator that was obviously different than the group of control, so it will be a reason that we could make a statement that the specific type of medical substance that we've give or we have gave so for the group of that so received the the substance could so contributes to improve a specific type of sickness, a specific type of disease, then we could get. And then so the TRIZ was kind of made was kind of a scientific methodology, but obviously applied in the learn. So we have not like have a testing what it was. We look for hindsight, and then they look for the patterns and see what were the patterns that gives for the solutions, in order to obviously we in the future we follow the same ones and apply in other fields to discover new things. So basically the people have analyzed this, they have analyzed so the all type of inventive solutions that were created, and we try to got predictable patterns and so can be put in the practice in order to create new things. But what were the main principles that we have got? Problems and solutions repeat across industries and disciplines, so meaning there are universal patterns of innovation. Contradictions drive innovation. The best solutions result trade-offs without compromise, and ideal solutions eliminate the problem entirely instead of just improving a flawed system. So real-world examples: automotive industry, the seat belt versus the airbag. So seat belts keep people safe but restrict movement. So it exists like a trade-off. So people prefer to have more type of security, and they kind of so sacrifice the flexibility that they've got. So it's a classic contradiction. It was a trade-off that to give one more of a thing, I've kind of so gave away another one. And then so TRIZ helped engineers develop airbags which provide protection without restricting movement. So in that type of case, it was not needed to get a trade-off that I give something that was positive now a bit more negative in order to something that's negative to become positive. What is ideal is not so have these trade-offs to happen, is just solving the problem without creating another one. Smartphones, bigger screens without bigger phones. People wanted bigger screens but didn't want bigger devices. The solutions: foldable screens TRIZ teaches that solving contradictions leads to breakthrough innovation. So a TRIZ was another pattern that TRIZ tends to look for, was as well something that was applied in smartphones. The space pen versus the pencil myth. So NASA supposedly it spent millions developing a pen that works in space, while the Soviets just used the pencil. In reality, both faced a contradiction. Writing in zero gravity without debris. The actual TRIZ inspired solution, a pressurized ink pen that works in space, underwater, and in extreme temperatures. So another type of example. So now that I've given some examples, what could be a good way in order so to get the most useful thing that could be got from this is using and understand what are the principles. There are 40, there are a lot, but then so what could be examples and how so to apply them. So the first type of principle, segmentation. Divide the object into independent parts or make it modular. Example, the Legos, the modular computers, the detachable iPhone. So by having segmentation of something, divide the object in independent parts, by making it so modular, you can have solve problems in easier way if it happens with the device, because if it just happens in one of the components, by being in models, you not have like to work and to having a probability to make all the to destroy all the things that were not so weak. And then so if exists a problem just in one specific part, you take away and you just solve it. It's like the way that solves that we can have a problem or whatever is a cancer or other type of thing, we just treat in the organ, operation in the organ, but because exist models, organs are like models in our body, and so we don't have the need of taking the whole everyone, and obviously so making it creating some problems, and then so we just treat what is already bad. Another principle, extraction. Remove or isolate the problematic part of the system. Aluminum-free deodorants to prevent allergies. That was I've talked about. Segmentation allows extraction. That's so one of the best tip of things that could be present that makes so our life easy when we want to solve a problem. Another component, local quality, change a specific part of the system to improve efficiency. Example, tires with different threads for better grip. So depending of what the context requires, you change a specific part of the system to improve efficiency without having to change all other type of components, since just one of them is like the bottleneck to you to have a better performance. And then so by being segmented, having segmentation, you have a possibility to extract and just change by making replacing or even cuts away to reduce the complexity of the system. We have another one, asymmetry. Modify a symmetrical shape to improve performance. Example, airplane wings are asymmetrical to generate lift. So another example of asymmetry can create a solution. We have other one. Merging. Combine objects or functions to save space or time. Example, a multifunction printers. Scanner, you have the ability to be a scanner, a copier, and a printer. So by merging and having the ability of a specific object to make a lot of different functions that rather than have specific device that just do one specific type of solution. And then so you have one that can make the three functions. You economize time, you economize space, whatever is the resource that obviously will be useful in a world that has limited resources and the people have almost so unlimited type of needs. Other principle, universality. An object that performs multiple functions, reducing the need for others. Example, Swiss Army knife. Nesting, or it's called the matryoshka principle. Place one object inside another to save space. So example, foldable cups or stackable chairs. Other example, counterweight. Use opposing forces to balance or for balance or stability. Example, the elevators use counterweights to reduce energy consumption. Another concept, prior counteraction. Anticipate problems with preventive actions. Example, ABS braking systems prevent skidding. Another principle, Prior action, perform action in advance to facilitate a operation. So preheating car engines before the takeoff. Caution in advance, create safety solutions in case something fails, or redundancy. Emergency parachutes for small aircraft. Equipo potentiality, reduce or eliminate unequal forces in a system. Properly inflated car tires prevent uneven wear. Inversion, do the opposite of what is normally done. Instead of taking patients to the hospital, mobile hospitals go to them. This is the example of inversion. Curvature increase, use curved shapes to improve efficiency and resistance. Rounded helmets for better aerodynamics and safety. Dynamicity, allow a system to adapt to external conditions. Car wheels that adjust to rough terrains. So these already, I will give a break for that. I'm gonna continue calculating all other principles in TRIZ, and then so I expect you to be present in the next video that we're gonna continue talking about the TRIZ principles that were so catched by this engineer, that were like patterns that is seen repeatedly happening and repeatedly be like things that people have used to create new things. So I expect this video has helped you, and see you in the next one.